Hello. So, we've talked about PPE, we've talked about definitions, talked about mixers. So we're getting close to actually making some concrete. But before we do, we need to know how to make our specimens, right? If we just have a big container of concrete, there's really not much we can learn from that. We have to make it into a testable specimen. And I would say the most common way to test concrete is with a 4x8 cylinder. Now, 4x8 is talking about diameter versus height. So this is 4 inches in diameter and 8 inches in height. 4x8 cylinders allow us to do compression testing, which is very common for concrete, as concrete is usually used in a compressive setting. So compression test is we, make our cylinder, we demold it, we let it cure in water or humid environment for however many days we've specified in our testing sheet. And then we put it into a machine and we crush it. And the weight under which it fails is its compressive strength. We can also do some indirect testing. A compressive test is a direct compression test, so you just crush it. We can also do an indirect tensile test, where we can determine our tensile strength of the concrete from, again, crushing it. But this time with the tensile test, instead of straight up and down, we can go side to side. So we have our plate down here, plate up here, we crush it, and we can get some very valuable data about our actual tensile strength. Fun fact, the compressive strength of concrete should always be about 10 times the tensile strength of concrete. So just put that in perspective. A typical concrete, like beam or whatever, is going to be an A4 concrete. A4 concrete is very common. A4 is a designation, and then VDOT designates that as 4,000 psi or above. So if we had a 4,000 psi compressive strength concrete, and again, concrete's always classified, or almost always classified by its compressive strength. If we had an A4 concrete, which is 4,000 psi compressive strength, then its tensile strength would be 400 psi. Maybe you can start to see why building a canoe out of concrete is a bad idea, as most of a canoe is under tension, not compression. But all that aside, let's get to making the cylinder. We're going to assume this bucket of sand is a fresh batch of concrete. Now, you'll notice I'm not wearing a mask. That is, and this is of course a fantasy scenario, but fresh bucket of concrete, I'm not wearing a mask. Why? Well, once the concrete is wet, and once we have taken it to a new environment or been in an environment with adequate ventilation, such as the fume hood or outside, you don't really risk much dust for breathing. So all I need to make a cylinder now is gloves and safety glasses. And I appear to have chosen the most scratched pair of safety glasses in this whole lab, so everything's very blurry. So, making a cylinder, it's completely empty. I don't have a scoop, so we're gonna do this barehanded, but that's the best way to scoop concrete, that way you can really get a feel for it. Because as concrete canoe people, you're gonna wanna know how your concrete feels before you actually end up placing it on pour day. Because if it has amazing strength, but you can't place it on a shear side, such as on a canoe wall, there's no point to your concrete. You don't want self-consolidated concrete, which is basically a liquid, when you're trying to make a canoe. So, we have now filled this cylinder up halfway. I don't know if you can see that with the camera. That is the proper way to do this. You fill your cylinder halfway with cement, and then you have an ASTM rod, which is a standard size. I couldn't find one, so I grabbed a number 2 pencil, which is actually close enough to the same size that if you're really in a bind, just use the eraser part of a number 2 pencil and pretend you didn't know what happened if the cylinder doesn't turn out right. So, we're gonna rod this 25 times on the first lift. And of course, a lift is how many times you fill it up, right? So our first lift, we fill up halfway, and then we're gonna rod it 25 times. And those 25 rods, you want, I should say, what I do is I do about 10 to 15 on just the outer edge, following the edge of the cylinder completely. And then the last 10 to 15, of course, adding up to 25 total, you choose which one you want to do. Doing sort of a Fibonacci sequence down to the exact center of the concrete. You want to have a very even compaction all the way around. Now, there is a standard which allows you to vibrate concrete, which is in this case, if I had this cylinder and this full of concrete, I could take it to a vibratory table, put it on there, push it down tight, and vibrate it until the concrete started to bleed. When concrete bleeds, that's just when you can see water start to come out of the solution, or matrix, or whatever you want to call it, the mixture. When you see water start to come out of the wet or fresh concrete, that's bleeding. So typically, put your concrete down, you vibrate it until it starts to bleed, you take it off, do the second lift, you put it down, vibrate it, take it back off, strike the top, you're good to go. Concrete Canoe uses lightweight concrete. You really are not supposed to vibrate lightweight concrete because it simply does not have, as I've been told, the mass to consolidate itself. It's like vibrating cotton candy. It's not going to do anything. You got to push it down. So we're going to do that. I'm just going to rod it 25 times and find this count. Oops. Okay, so I've now rodded 25 times, and by standard, you're supposed to give this thing a good tap. Now, there's a certain type of hammer you're supposed to use. It's called a rawhide hammer. It's not actually, it's not made of rawhide. It's just a wooden handle with 2 rubber ends, or plastic ends. Sorry, not rubber. And you just give it some good taps on each side. Again, couldn't find one, so I'm just hitting it with my hand to sort of show that. But it's about 3 taps on each 90 degree. So now we fill our halfway, our first lift, we've rodded it, we've tapped it, and now we're gonna fill out the other half. Trying not to dump sand down my sleeve or on the table. It's much easier, I should show this from the beginning. So, with your concrete, you should probably overfill when you do this. Main reason for that is you're about to compact it, and it's better to compact down to the level you want than try and fill back up to the level you need. I'm not doing that because this is sand, and I don't really care about this all that much. So, when you rod the second lift, you want to go 1 inch into the previous layer. So to give an example of that, I sort of filled out around here between these 2 sets of lettering. So actually I think it was right above, right above. I need to go down to that. So I rodded to right above this set of lettering. So I'm gonna take my rod, which pencil in this case, and I'm just gonna measure it down to about where I need to go. About right there, which is about 1 inch into the first layer, or first lift. And I'm gonna grab my rod there, and I'm just going to use like my hand itself as a measuring guide. Because I know if I hit the edge of this cylinder, that's all the compaction I need. Okay, I've rodded, but I do not have enough height on my cylinder to make it a full cylinder. So, I'm going to put some more sand on and really pack it down. And do a nice little tap. Again, you should be using a rawhide hammer for this, but I don't have one. Or really any hammer. You don't want to be like whacking it though. You're not trying to, drive steel here. You're just trying to give it enough sort of vibration to consolidate it a bit. So, we're going to call this a perfectly prepared sample. It's not, but stick with me. So now, there's always one last stage for any good concrete. And that is striking it off and making it a smooth finish. When we test a cylinder, we need a smooth top to that cylinder, as well as a smooth bottom. The bottom will be taken care of because it's, of course, a plastic cylinder on a plane, so the bottom's gonna be smooth for us. So we have to concern ourselves with the top, getting that smooth and getting that testable. you guys are all engineers, I assume, who are watching this, so you're going to know that testing on a flat plane is going to be a lot different of loading than testing on like a 45-degree angle. You can draw up in the free body diagram with your statics knowledge if you want to, but I assume you just kind of get that intuitively. So, there's a lot of ways to do this. Again, if you're in a pinch, you can just use your striker bar, or your rod, or pencil in this case, and just sort of, shake it across until it's nice and flat, and of course, building it up on either side, smoothing it out. The flatter you are, the better it is. You're gonna get much better results. You can get much more consistent results if you're flat and well compacted. So we shake side to side. We just compact again. And anything you compact by hand is not the best. You want to do most of your compaction by rodding, but sometimes you can't get it perfect. So you strike it off. And it's good to go on the 90, right? So you go, 180, 90. It's good to go on the 90. So you go like north-south and then east-west, and you can get a very nice flat surface. And then, once you have done that, you take your cap, you lid it, and you let it sit for 24 hours. 24 hours after you've made it, plus or minus 30 minutes, you can demold the cylinder. I'm not going to cut this cylinder for no reason, so I'm not going to do that. But 24 hours, plus or minus 30 minutes, demold the cylinder, and you get it into whatever curing situation you guys are using at this time. So if you're still using a water bucket, perfect. If you're using a humidity tip, great. If you've managed to get a moist curing room with the construction of a new small building or something like that, that'd be even better. But that is how you make a cylinder. And you can see the top is very flat, very flush with the cylinder head. And then dump it all in there. Cylinder's nice and clean. That's how you make a cylinder.